Hi there, it's nice to see you all. I hope you're having a great day. We saw some great sessions already. So let's head for next station, Korifi. We're all together in this room because we're into Cloud Foundry, we like the experience, we're using it, and we see value in it, but there is an elephant in the room, right? There is Kubernetes. We can't deny it, so I'm sure that all of you know about it. I'm sure that all of you tried it. So what do you think? How do you find it? Isn't it difficult trying to run your code on Kubernetes? Because you first need to build your code. Then you need to put it in a Docker image. Then the Docker image needs to be pushed to a registry. And at that point, you start writing YAML, like hundreds of lines of YAML, only to get your app running. And if you're coming from Cloud Foundry, like we all are, we should be wondering, does it need to be that hard? Can we just not push our code to the cloud? So now I'm Georgi, this is my colleague Dani, both SAP engineers, and we're here today to share a vision and a journey. And this is the vision of bringing the familiar CF push experience on top of Kubernetes, and our personal journey of bringing that vision to the SAP Business Technology Platform. So maybe you're wondering why we picked up these funny pictures instead of our real faces. Well, we figured this is how we look to the community anyway. Like you saw, Beihan already showed the leaderboard, and this is what I look like. And if you look us up on GitHub or you join our Slack, this is what you're gonna get. So let's continue. Like we're here to share about our journey, and each journey needs to start somewhere. And for Dani and myself, it all started quite a few years ago when we started working on the CF Garden project together. I'm sure you all know about Garden. This is the steam engine of Cloud Foundry, like doing the heavy lifting, isolating processes, low-level Linux primitives, long before Docker was a thing. So this was quite an exciting project to be on, and we spent many years working on it, but while we were doing that, the clouds were shifting. And Docker became a thing, Kubernetes became a thing, you know, the elephant in the room, everyone started talking about it. And a part of the CF community started wondering, maybe we should follow suit. And this is how Korifi was born. Korifi is a foundation project. We have our own working group. Danail and I are among the top contributors, as you can see, although we're nowhere near the levels of the dependent bot. We wanted, like, the dependent bot really wanted to join the party, but we decided to leave him behind because someone has to do the real work, we figured. So yeah, Korifi is a community project. Put simply, it has the goal of delivering the Cloud Foundry experience on Kubernetes, and as you can see, it's been pretty active the past few years. So let's dive straight into some technical details. What is Korifi and how is it going to deliver this experience to Kubernetes? Well, how do you do just about anything on Kubernetes? You start by defining some resources, right? So that was the first thing we did. We started thinking how we can model a Cloud Foundry application in terms of Kubernetes custom resources. And we started designing resources such as application. We had org and space, services, bindings, like you name it. All the CF lingo that you're familiar from your daily work needed to be mapped to Kubernetes resources. And once we do that, someone needs to create those resources. So obviously, you can do this with a kubectl, but this is not really the point that we're trying to make here. So we implemented a CF API implementation that runs on Kubernetes and knows how to map V3 API calls to these custom resources so that we can have our application model on Kubernetes. Which is great, but at this stage, nothing is really happening here, like just metadata. So we bring in some controllers, the Korifi controllers, and these guys know how to translate app custom resources to runtime resources, which is yet another layer of metadata, not much useful. We need to translate this to native Kubernetes things that actually run and do some useful job. And for this, we have defined a couple of subsystems. we have a builder subsystem, and you heard in the previous session about cloud-native build packs. So our builder system uses KPack and cloud-native build packs so that they can pull your code from the package, build it, and push it to a Docker registry, exactly what would happen in Cloud Foundry. And arguably, this is the main and most tedious part of running your code on Kubernetes. So that's what the builder is doing. Then once we have an image, we need to run it somehow in a pod. So we have a runner that knows how to translate our resources into a stateful set that will be running your image on Kubernetes. And in order to access your app, provided that you have a root, there is a networker that knows how to create native Kubernetes networking resources. And this is more or less the generic architecture of Korifi. Now, the interesting bit is that all the components that are grayed out on the slide are actually, you can turn them off or swap them away completely. Because, for example, you might not really want to run stateful sets. You might want to run deployments. Then you're covered because you can turn off the default runner, and then you can write your own runner that runs deployments. And I promise that it's not very hard to do, as you'll see next on. So it's a very thin layer. And as you can imagine, you can also do this for networking. You can do it for building images, you name it. And if you're engineers like us, you probably start seeing some potential in this architecture. But what you don't see is a fundamental problem that becomes more apparent on this slide. So here is myself, here is Dani. We both work for SAP, so SAP pays us money, and we spend our days basically full-time contributing to this cool open source project, Korifi. But the question is, what does SAP get back from their investment? And as of today, there is not a very good answer. So that's not a great situation to be in. I'm sure you can think of a couple of reasons why. And basically, both as SAP engineers and as community members, we decided it's our job to change this. Like, why not find a good fit for Korifi in SAP? So we turned to the SAP Business Technology Platform. And in terms of runtimes, you have pretty much two options there. If you have a 12-factor app, we have big Cloud Foundry deployments, so that's why we're here. We're sponsors anyway. So you can just push your app on Cloud Foundry, problem solved. But if you have cloud-native apps, we have Kima. And Kima, for those of you who are not familiar, is pretty much a Kubernetes cluster. They put some salt on it. It's an SAP commercial offering, but for today's exercise, this is a Kubernetes cluster. So maybe that's good salt to put Korifi on. Because you have cloud-native applications, put them on Kima, but why not give you the convenient Vitro API as well, so that you can push 12-factor apps. And we thought this is a great way to extend maybe our offering. And we took our charts and started spreading the word in SAP. We have been working for the company for a really long time, so we know a lot of people across orgs. So we just started chatting about this, advertising our efforts. And people said, that looks interesting, we'll come back to you. So we sat down and waited, and waited, and waited, and nothing. No one really came back. Needed to say, we were very disappointed, but we continued contributing to the project. But then, at some point in time, like a couple of months later, we got contacted by some colleagues working for the SAP New Runtime. This is SAP's first cloud offering. It is primarily targeted at running Java apps. And over the years, it has accumulated a really big user base. I think it was launched back in 2012 or something. SAP decided to sunset this runtime, so our colleagues had to make a choice. They had a challenge where to migrate their customers to. And as you know, we had two options, so Neo had to choose. Problem is, whatever they chose, it was not a good option. Like, neither option was a great one, because it will mean a lot of cost for the customers. They had to completely rewrite their apps, either as 12-factor apps or as cloud-native apps. So a lot of cost for the customers, maybe consultant fees, and essentially a reputation hit on SAP. So these colleagues wanted to know if Korifi can maybe solve their problem, can maybe help them put their user base on Kubernetes. So they came to us, and we were more than happy to take the challenge. So we jumped right in and started an experiment. You have to understand how we basically do work in our team. We first think of a good name for anything. Like, you have to have a good name, then you have a good logo, and only then you're allowed to start actually doing some work so that you can prove some point. And it was all about running Neon Kate. So there we go. A couple of developers spending an afternoon like picking up all the fonts and things. And thank you, yeah, you have to appreciate this. And once we got, thank you. Once we have this vision, this logo, we set off to the drawing board. So again, we see the diagram of Korifi. First thing we notice, the new runtime has a different API. So as I said, most of these components you can turn off. First thing, we turned off the CF API and came up with a really thin implementation of the Neo API. It proved to be relatively easy to map Neo application model to our custom resources. And then it turned out that stateful sets are not a really great option for Neo. It's more complex than that. But luckily, those colleagues had already done some research, and they had a Helm chart that was capable of running their app. So we swapped our default runner with a Helm chart runner, and we could run the app, basically. The new app would come up on Kubernetes. Next thing, we had to swap the networker because at SAP, and especially Kima, it's sort of a rule to use Istio, and we're using something else in Korifi, but that was an easy one. And as for the builder, because of cloud-native build packs, it was really easy. The colleagues had already developed a build pack. They had done some research. And with this architecture, with this experiment, we were able to deploy a Neo application on Kubernetes, just like that, and we were super excited. It was a great success, and we decided that we have to make some noise again. So we triggered our network again, started showing it around to people, because for us this was a very good proof that this is a very powerful engine. Like, you can put Cloud Foundry on Kubernetes, you can put Neo on Kubernetes, maybe you can put just about any app model out there. So our colleagues said they're going to come back, but we waited and waited, and nobody answered. And we just didn't get it at this point. Like, what are we missing? We have this great prototype. It's running. You can see it. Like, we had a demo and all that, and no one interested. So obviously, we were missing something. We had the platform. Korifi is our train. So is there maybe a gap that we need to mind?
So, minding a gap starts with first identifying what the gap is and where it is. So after the very long wait, eventually someone called again, and those are our colleagues from the architecture governance board from SAP. So they have seen the Korifi project, they liked it, they liked the idea. They have also seen our prototype, saw potential in it. But most importantly, they had an idea why Korifi doesn't fly with SAP. So, according to their theory, a platform consists of several important aspects. First one is the runtime. This is the machinery that's responsible to run your workloads. Then you have users, which is basically being able to consume the user base from your platform. Then you have the services. You know, a platform is all about services. And last but not least is the dev experience. So, with regards to those aspects, we sort of had the runtime covered because we could apparently push Cloud Foundry applications. But as per users, yeah, you could use kubeconfig with your CF CLI to authenticate against the Kubernetes cluster. But really, working with kubeconfig is tedious, it's error-prone, and also doesn't support interactive authorization and authentication, which was a problem. So basically, we had to implement integration with UAA. Then services, yeah, user-provided services are great, but someone has to create the service instance for you, which is not that great. And for dev experience, regardless how much we like the CF push experience, a popular way of pushing applications on Cloud Foundry is deploying them as multi-target applications, which is something like manifest improved, Korifi at that point in time did not support it. So we saw their point and we realized that actually their theory makes sense, and we started filling up the gaps. So we had our well-known Korifi and started building. First thing we did was to deploy the multi-app controller service on our Kubernetes cluster. It turned out that this is just a regular application, so we just had to push it, made some minor changes to the CF API, but in the end it worked. With this, you can now CF deploy your applications. Now, next, we took a UA instance, configured it to talk to the SAP identity provider. That's the thing that provides the user base for SAP. And configured our Kubernetes cluster to use that UA instance as an OIDC provider. By doing this, we were now able to CF login on the cluster with our SAP users. And here we're using the SAP identity provider as an example, and also because this is our goal. But really, you can use any identity provider because UA is highly customizable. You can use Google, you can use GitHub, maybe your company identity provider, doesn't matter. As a bonus point, with this integration, we also achieved the single sign-on authentication flow, which is pretty user-friendly. And for managed services, we had to extend the Korifi controllers to support managed services over the OS BAPI interface. We've implemented a very thin service broker that was able to consume services from the BTP Service Manager. This is the registry that SAP uses to provide services to its clients. And provided that this is the OS BAPI interface, you can actually not only use the BTP Service Manager as a broker, but you can use any existing service broker. So by achieving this picture and implementation, we actually managed to push a typical Cloud Foundry application that consumes SAP managed services, and we were also able to do this authenticated as our own users. So now we want to show you what we've got. I would ask Georgi to give me a hand because talking and typing is hard. So we have our prototype deployed on a Kubernetes cluster, and we have implemented a simple monitor at the lower part of the screen that would let you see what resources we have on Kubernetes. Right now it's empty because new cluster. So first thing, Georgi is going to target the CF API. Okay, next thing is login using SSO because it's so cool. So here, note.
Guys, increase the font a little bit.
Georgi, can you increase the font?
We can try, but I don't know if this is not going to get in the way of the monitor below. I'll try. So let me place the token.
So Georgi took his token for his user, and now I can see that he's authenticated as his user, not any random guy. Okay, let's start the usual org space dance. Let's create the org. Okay, the org is created. You can see the CF custom resource for Korifi and the Korifi namespace that backs up that custom resource. Now let's create the space. Okay, another CF space custom resource for Korifi and another namespace that backs it up. Let's target it. And now we're ready to have a look at the demo applications that we're going to show you. So our demo application is a very simple product list application. We're going to push it with a standard Cloud Foundry manifest. Although it's a web application, it's written in Go because why not? It also uses a service called XSUA. XSUA is one of the most notorious SAP services, basically used to authenticate and authorize users. So it gives your application the ability to log in and control what you can do with this application. Yeah, so let's do it. We need to consume this XSUA service, so the first thing we need to do is to bring our broker in. So let's create the broker. here you see the service broker resource created, and let's have a look what services it offers. It offers quite a lot of things. For this demo, we're going to use the XSUI service and its application plan. So let's enable it. Cool, and now we can see that in the marketplace. Okay. Yeah, next thing would be to create the service instance. So we configure the service instance with a parameter object. Let's have a look at it. It's a JSON configuration that configures the XSUI service. The important thing is that it defines a thing called row collection called product list viewer. This is basically the permission your user needs to have in order to be able to see the products. Let's see how our service is doing. Okay, it has been created, another Korifi customer resource created, and we're ready to push. Okay, push started. We have our manifest. You can see that in the meanwhile, Korifi created a application customer resource for the application, a package that describes your source code, and a build. That build triggers a kpack build, which runs Paketo build packs under the hood. We can see that the build pod is now running. It has 6 init containers. Each one of them corresponds to the build phases of the build pack. You can see now the build running. We have the Golang build pack processing our application. Once the build is finished, it's going to produce a container image that contains our application and push it to our container registry. Usually takes about a minute. Maybe time not sufficient to tell a Kubernetes joke. Okay. So the build is done, and our application image is being pushed to the container registry. And yeah, the build completed, and now our stateful set is going to be created, and our pod that backs up the application is going to start. Cool. We managed to push. Let's have a look. Okay, now let's access the application by the route provided by CF push. The application is going to log in Georgi because he has certificate imported in the browser, but he recognized that this is Georgi, and Georgi doesn't see any products. Let's fix this. Okay, now Georgi is going to assign this row collection or this permission that he needs to see the products. And if we navigate to the application again, yeah, here are products. So, thank you. So if you are aware of any SAP market materials lately, you should know that SAP is committed to making the world better. So we plan to bring our prototype implementation back to the open source Korifi project. Right now we are working on the experimental support for managed services. It's probably going to be the highlight of our next release. Then we think about optional integration with UAs so that people can integrate with their identity providers with Korifi deployments. And until then, make sure to check out the Korifi project, maybe give it a try. Running it locally on your Macs or laptops is pretty easy, literally single liner, but do check the documentation. We would like to get your feedback. Maybe you can contribute some PRs, feature requirements, whatever. It would be greatly appreciated. So there you have it. Here is my source code. Run it on the cloud for me. I do not care how. This is the Cloud Foundry haiku, a promise that has been given a decade ago. During that decade, technologies have changed, but the promise is still kept. Thank you.